So here we are going to prove that if we have a 1-1 linear transformation from Rn to Rm and W1, W2, and so on and so forth up to Wk, that is this subset of k vectors is a linearly independent subset of Rn, then the image set of these vectors will be linearly independent subset of Rm as well. And we will not use this directly in our proof, but it's good to note that k has to be lower than n in this case, and because the transformation is 1, 1, n has to be less than or equal to m. So anyways, so here we have to show that if a linear combination of these vectors is 0, then the coefficients involved will be 0 as well. Okay. So again, if a linear combination of these vectors is 0, then what we must show is that all these real numbers a1 through ak will be zeros. So if this t is a linear transformation, then this linear combination will be image under T of what? The linear combination of these vectors by the same real numbers. All right. So again, because T is a linear transformation, this quantity is what? This quantity is image under T of this linear combination of these vectors W's. Okay. Now, since T is a 1-1 linear transformation, what that means is this, that only zero vector can go to zero vector. That is, if the image of v under t is 0, then v has to be 0. And this is because of the fact that t is 1, 1, right? Okay, so let's just stress it again. Okay, that is, you saw that the kernel of t will be only 0 vector. Okay, so now again, because of this argument that we have, since the image of this vector is 0, okay, all right, I'm sorry, just a moment, okay, so the image of this vector is 0 means this vector itself is the 0 vector. Now remember this, all these vectors w1, w2 up to wk, they are linearly independent. So what that means is that all the coefficients, these real numbers involved, will have to be zeros, right? So therefore, as I just said, that all these coefficients will have to be zeros. That is, just a moment, it should be not W's, these should be A's, I apologize. Okay, so these should, okay. So all the A1, A2 up to AK, they will all have to be zeros. So what we just saw is, if you look at the conclusion, that taking this assumption gave us what? Gave us that all the real number coefficients involved will have to be 0. So therefore what we have is that this is a linearly independent subset of Rm. All right.